let's sketch a cuboid out. So I'm going to say that this length is A, this one is B, and this one is C. Of course, we've got more lengths behind. So we're told that the sum of the 12 edges of a cuboid is X. So I am going to get 4 lots of A when I add the edges up. Here we are. But I'm also going to get 4 lots of B and 4 lots of C. Those are my 12 edges. And that's going to equal X. We could rewrite that as X equals 4 times A plus B plus C. We'll just put that to one side for the moment. We're then told that the distance from one corner of the cuboid to the furthest corner is y. This is called the space diagonal. Here we go. This is y. And I can use Pythagoras' theorem to help me work that out in terms of A, B, and C, because that length there is going to be the square root of A squared plus B squared, because I have a right angle triangle along the bottom, which means y squared is then going to be that square root squared plus c squared, because now I've got this black triangle here in 3 dimensions is again right angled. So that gives me a squared plus b squared plus c squared. And actually this is a 3D Pythagoras' theorem. Okay, you could have gone straight there potentially. Right, so 2 results for the moment, just underline them. Now we need to bring in the surface area. So the surface area is going to be, well, A times B would give you the base and then you double it. So you're going to get 2AB, then you're going to get 2AC and 2BC. So we can just write it as 2 lots of AB plus BC plus CA. Now we just have the small matter of somehow rewriting that in terms of X and Y. Now in Y, we've got y squared, and I don't want to really square root this at the moment, so I somehow want to get the surface area in terms of some squareds. And I've got X, but that just has A, B, and C. So what I thought about doing is like there is a nice result you can use, which I'll talk about at the end. I mean, I didn't know it, but it makes sense. Yeah, I just went ahead and squared X. I thought, let's just go for it. So then I'm going to get 16 times A plus B plus C times A plus B plus C. So that's going to bring in my A squared plus B squared plus C squared. Let's just see what happens. So I'm going to get, do you know what? I'm just going to write A squared plus B squared plus C squared. I'm going to get 9 terms from this, as long as I'm kind of careful enough. Look, I'm going to get A times B, but also B times A. So that is going to give me 2AB. This is good. But I'm also going to get A times C and C times A and B times C and C times B. So it ends up becoming 2BC plus 2CA. You can do it more carefully than that, but that is correct. I've got 9 terms from it. So what does that mean? That means I've got x squared is equal to 16 multiplied by y squared, because that's what that is, plus the surface area. Okay, and through squaring x, we've managed to get an equation that links x, y, and the surface area. So I can now divide through by 16. X squared over 16 is equal to y squared plus the surface area, which means the surface area is going to be x squared over 16 minus y squared. Just need to check that that's there. Maybe they put it over a common denominator. I think they did. So we could write it as x squared minus 16 y squared over 16 if we wanted. It gives us an answer of E. So I did talk about a nice result you could use. I mean, here it is. So the surface area is actually equal to this, and then you can like link it together quite quickly. But look, I'm not expecting you to know what that is. I'd say like, that's something to take out of this video. There are lots of results out there. But the way I did it, just by constructing it, like following my thoughts along the way, thinking, how can we link it together? Let's just try and square x and it will work out. That's absolutely fine as well, really. I mean, the most efficient way, of course, just bring in this, but It didn't take too long to expand the brackets, so I'm happy with my method. Well done.